G'day, Wave Rover fans. I'm going to discuss with you the theory of the DC electrical system for Wave Rover. So we have a schematic drawn out here, and up here are going to be the 100-watt solar panels. There's 3 of them. The power will go down into a solar isolator panel, and that's located in the starboard berth at the aft end of it. And in there, there's a surge protection system, as well as a circuit breaker type device that can be flipped off, and just at that point no solar power is going to get beyond there.
So that's a gray plastic box that you'll see shortly, and it's located at the foot of the bunk on the starboard side.
And then so from there it goes to the MPPT, which is the solar control unit, and that regulates and perfects the power coming in from the solar panels to it.
And it's a good deal oversized. At we have,
it's a 100 by 50, so it's capable of 50 amp and 100.
So we don't have to worry about going anywhere near the capacity of that controller.
No. So looking on the positive side, it goes into this green device, which is a terminal fuse block on a battery bus. Sorry, losing my words here. From there, it goes on into the batteries through another terminal fuse bus there. So that's how power is being conducted to the batteries through the positive system. If there's a demand from the batteries, it comes back up through to the bus bar, over to the battery control switch, through the battery control switch to the main bus bar for positive. From there it'll feed up into our distribution panel, which is the switch panel on the nav station. Going back to the MPPT, the negative system will go down to the shunt. And the shunt is what reads and tells how well the batteries are being charged and how much they're being discharged, and if there's any system. This blue line here goes to the battery monitor panel, which is a Bluetooth device, and can be shown on display on the nav station as well. Going over from the shunt, we have our negative main bus bar, and we've decided to go put in a small 2,000 watt inverter to control that power down below. We're going to use a continuous power relay there, which will be switched through the distribution panel. And that 2,000 watt inverter will just have 3 AC 110 plugs coming out. And when you're in port or whatever, you'll be able to charge up your computer and use your computer. So also from the distribution panel, we have our navigation lights, our VHF radio, our cabin lights, and there's the common bus bar that'll all go back to our common negative system. As well, on the nav station we have our 12-volt accessory outlets and USB outlets, and they all get controlled through a switch on the distribution panel through a common bus bar for the positive control. And again, they all have a 10 amp fuse built in.
And I believe we're also going to put a switch for the distribution panel because it's all lit up with LEDs. You'll see this in a few minutes, and it'd be nice to be able to just turn off those lights so I can have a dark ship at night.
Exactly, and that's just a matter of putting a switch, having one going to the common and one going to the positive, and with the interrupter to there's a position right here, a pole position there for those LED lights.
Excellent, excellent. Well, there's a lot to do. Time to crack on with a little bit of electrical work.
You bet.
The Wave Rover 650, a design based on my single-handed ocean voyages. She's small, light, but easy to build, and strong enough to cross any ocean. My name's Alan Mulholland, and this is the Wave Rover story. So we're doing the electrical right now, and I'm very fortunate to have Stephen here. And Stephen and another fella named Ray over in Ireland have been working on the electrical plan, and we've got it worked out. Now Stephen is going to take over. He's going to explain all the little bits and pieces that go into this, and I'll just be labor.
So there's going to be a number of different segments, but this particular box here is going to be where the solar panels feed into with their electricity. And you can see the receptacles on the bottom, and then you have the output ports here. The nice thing about the solar isolator panel is we can use this circuit breaker right here to turn it on for the solar panels and then turn it off. As well, it has surge protection, and each of these inlets for the combining. So all the commons are combined, and then across the top all the positives are combined. And through that, each of these has a 15 amp circuit breaker, or sorry, correction, has a 15 amp fuse there, and that makes it fusible, and so if there's an overload, it'll protect Wave Rover's electronics. Same for the surge protector. If there's a lightning strike, hopefully it'll protect all of the electronics that are attached throughout the system. So here we are at the very back end of the take two. Here we are at the very back end of the starboard side berth, and the combiner box and solar isolator is now installed. You just use 4 screws, and this is where the main electrical from the solar coming in will go. And then we have the outlets here that'll go to the MPPT in the battery compartment. The next component to install is going to be the MPPT Smart Solar Charge Controller. So from the distribution box, the cables come forward and go to this device. This one will sort out any sort of flaws with the electrical coming in from the solar and make it absolutely perfect. And then from this, it goes into the batteries. So the MPPT is now in place, but it has to be mounted on a non-flammable substrate. So we have to get a piece of sheet metal to shield the plywood backing. And that's a simple matter. So there. And you can see the batteries are now in place here. They'll get strapped in, and other components to go into here are going to be the battery control switch, as well over on this side will be the shunt, and the main DC negative bus bar and the DC positive bus bar. So the next device to be installed is going to be the shunt. We have the battery power that comes in here, and it goes through and across, and it goes out to our common bus for negative, and our charge controller will all feed into this side. So we've installed the DC common bus bar, or negative, and the electrical shunt in the battery compartment. So the next components to be installed are going to be the DC positive bus bar and the system on-off control switch. The 2 positive DC bus bars, the MPPT will come to this. From this will go to the switch, which from the switch will go to the main DC positive bus bar, which will feed up to your panel and your switches for your loads up there, and you'll be able to control everything from there. Again, this switch here, that's off, and it shuts down your whole load system. If you were to switch off your solar panel isolator,
way back aft here,
way back aft in the berth there, that would switch off your solar panel feed to the batteries.
This is awesome.
So we'll get it all installed.
This is Flight Engineer Marinelli doing the electrical. Thank goodness.
So, and it's all going to be fused and properly sized for cables. So for the main electrical panel installation, we have 12 volt cigarette lighter outlets. We have USB outlets. We have our main distribution panel that is fused for each circuit, has a fuse built in. We have our Victron monitor for monitoring our batteries performance, and we have a USB-C outlet there for charging of the tablet that Alan has now. Behind looks like a rat's nest currently. We have a lot of work to neaten that up. As well, to go in behind there is going to be the cable splitter and the transponder for the AIS-B, and that'll feed up and join in with the VHF radio that's going to be mounted up here.
So we've had a busy morning. We managed to sand the entire exterior of Wave Rover, prepping it for what will be a paint job, hopefully in a few days. And right now, Stephen's back to work. He's doing the electrical system, which is such a time saver for me. Allows me to get other jobs done. And right now, why don't you let us know what we're doing right now, Stephen?
We are crimping up cables from the battery to the positive bus bar, thus color coded red. So we're crimping on, and I don't want to forget to add the heat shrink. It's hard to slip it on over afterwards. So we put that on, and we insert our lug end.
Right.
And then we have a hydraulic crimper here.
Very nice.
And I just want to make sure the orientation of the two cables is the same.
Yes.
Instead of being twisted 90 degrees, because that'll put undue stress on it. We open our collet here, and the valve is closed, and we just start pumping. Just gotta make sure.
Yep.
A little tricky here. New toys, new tools.
Well, that, and you're working on the quarter deck of Wave Rover.
Yeah. Little better light out here. All right. Coming up on the pressure, and we're just starting to crimp it. And it's nice and tight. And that is not going anywhere.
That's the way we like it.
We'll take the heat shrink, and this is marine heat shrink, so it has a glue in it, and it'll form a nice watertight seal around the cable end.
Nice, very nice. Are you doing that right now, or are you doing that later?
I'll be doing that in a moment here. I just got to set up a cable or electric cord for the heater.
Here, let me grab one for you.
Got it.
Boss has to do everything.
Now, this is supposed to stand effectively on its own.
Oh, never heard. I've got able-bodied Mr. England here who can probably reach out and hold it for you.
Let's see here. Let's see if it starts to shrink up here real quick.
Kind of like roasted marshmallows.
Just a little bit. Could be a little chewier.
Kind of a metallic taste.
I don't know if you can pick it up on camera, but you can see a little bit of glue coming out of the heat shrink there. It's
yes.
Shiny silver.
Yeah.
There. And that's what gives it a perfect little seal. Go.
Okay.
First cable manufactured.
Looking good. All right, well, it's back to work for Mr. England and myself. We're building a new yard. Do you have any words of wisdom to share with the Rovers?
No wisdom today, my friend. Not an ounce of wisdom.
All right, I'm sure there's something in there.
So working on the DC electrical system, you can see all the positive connections are on the one side, the cutoff switch, the bus bars, and the smart solar charge controller, well rated for there. We have two 100 amp hour batteries. Over here we have the shunt, and then the main negative DC bus bar. Number of connections still to be made up, but it's coming along nicely. We just finished installing the 3 wires to go from the MPPT back here to the solar isolation panel. So you can see the 2 red and the 2 black. One goes to ground for the surge protection, and red and positive for the MPPT power supply from the solar panels. It's going very well. It's fairly easy to install, 1 wire at a time.
So I'm inside Wave Rover with Stephen. Stephen graciously gave up his weekend and came over here and worked on Wave Rover's electrical system, and it's all located for the most part in here and right here. So we're calling the starboard side the nav station. Now, Stephen, do you want to walk us through what you got done this weekend?
Sure. We've assembled and installed a number of major components for it. We have the 2 100 amp hour batteries down here. Manufactured all the red cables and black cables for the positive and negative system. Pardon me. Up here we have the on-off switch for the battery control, and right in behind it we have 2 red bus bars and the MPPT. So and then if you look aft.
No, Stephen, I just want to ask you a couple of questions on the wire gauges. Do you want to explain? You know, of course, you need the heavy wire, but do you want to explain what kind of heavy wire and what its purpose is?
Yeah. So for the major battery cables, we're using 2 AWG gauge, which is a heavy-duty cable, and the idea behind how much electricity you're using through wires is to ensure that you're able and capable of handling the load. Too much load and you basically turn your wires into a toaster, and that's where electrical fires start. So appropriately sized with the lugs and connections will prevent electrical fires.
So we're the correct wire gauge, or are we actually oversized on our wire gauge?
For the batteries, two wire gauges there, but we have 6 wire gauge for the wires coming into the MPPT, which are oversized. You could probably get away with 10 gauge there, and then from the MPPT out is an 8 wire gauge there. As well, we have fuses installed in couple critical places. We have a terminal fuse here for the battery. This will protect the entire system. It's rated for 150 amp. And then for the MPPT feeding into the back into the batteries, and there's a 50 amp terminal fuse right here as well to help protect the system as well.
And what about this red switch? What does the red switch do?
So this is our battery control switch. It's right up is in the off position. If we turn it to the right, the system energizes all of our service requirements there. Going up to the nav station, we have a 12 volt cigarette lighter outlet, so the upper and the lower one, and then we have USB ports here on the middle 2. These also have on-off switches, and it'll also read right here. There's a little LED readout to show you how many volts is being supplied. Over here again is a USB-C type C port, and that's to supply your tablet, and as well you could pop wire into your computer to charge that as well from that. We have the solar energy monitor, or battery monitor if you want, It's used to tell you the condition of what's going in and out of your batteries, and if there's an issue with them. It's Bluetooth capable, so you'll be able to monitor it. If you're at your helm station there and you're just wondering what's going on, you can just open up your tablet or your phone and how goes it. So
right.
It's quite unique that way. Right here we have our switch panel, and each one of these switches has a 15 amp blade fuse, just like your car. The nice thing about that, you're able to get it anywhere virtually in the world that sells in cars.
They're not expensive. We'll just take we'll take replacements with us.
Yeah.
They're light. Yeah.
So for this, there's LED readouts. They'll be either red when it's off. If you flip it on, it'll turn green. But we're going to add in a little switch here to interrupt that circuit, so that the lights aren't on all the time if you don't need them.
That's right.
So,
it's nice to have the inside totally dark, so you protect your night vision.
yeah, and then on the back side of it, we'll flip it around. The wires aren't completed yet, but each of those devices has a 10 amp fuse built in, and you can see that this red bus bar here is strictly all the USBs and 12 volt outlets. We'll use this as one common one, and it'll be controlled by a singular switch on the panel. And this is just our common, so all of our normal loads for the radio, the lights, and that there will all have their common source here, and there will be a major wire going from this down below into that the main DC negative bus bar.
Now, what about this big space right here? What's that being reserved for?
Well, apparently you've got a Vesper XB8000 transponder and cable splitter, and that'll be a nice feature for you to have your AIS. That's the automated identification system for ships, and it will help prevent collisions at sea and monitoring. So it's a very nice device to have there.
And then just to round off the nav station, directly above this, on this shelf right here, this is where the VHF is going, and this hole at the back, that's where we'll have the connection with that VHF splitter for the AIS that Stephen just mentioned.
It's going to be a fairly robust system for such a small vessel. I'm thinking it's designed to have safety and utility all engineered into it.
Right on. Thank you so much, Stephen, for all your hard work this weekend and really bringing a high level of professionalism to the Wave Rover's electrical system. Thank you so much.
Looking forward to having it complete and neat.
Well, the Wave Rover patrons, with their pledges of support, really do make the creation of these videos possible. Now, if you'd like to know more about Wave Rover's patron page and benefactors bulkhead, I have links to both those pages in the video description. Now, another way to help Wave Rover, and it doesn't cost you a dime, is by sharing our content on your social media. So now, as always, Rovers, thanks for watching. Give us one more.